Good afternoon, Miss V.
Hi, good afternoon, everybody. Let me know if you guys are hearing and seeing, and we're going to begin today's revision session number 1. Okay, so first thing first, let's have our checklist of everything that we're going to be touching on. Today's focus is going to be number theory. And today you have to do some writing, okay? So all of the notes and everything that I am writing, I recommend you guys copy down because this is something that will be useful during your personal revision, okay? So when it comes to these topics, I'm just going to outline everything that you should expect to master. So I'm going to do out that list and then we're going to jump right into the actual revision. So I'm just looking for my remote. Give me 1 minute if I could find it. All right, so
Soca Brainwash, the connectivity of soca to music, spirit, and vibe that unites us all. When music so sweet, Ryan, do what you do. And when Ryan start got the big tunes. Hey yo, Ryan, you run it, please, that is the truth. When I show it back, Ryan in the room. When love you feels like a wind. At last, Ryan, not too much of the day. Long time, Ryan, that's when I am dead. Ryan, book it them, give it them, we get it finally. Ryan, make we dingo, dingo, Nina. Ryan, dingo, Nina. Ryan, make them dingo, dingo, Nina. Ryan, make them dingo, dingo, Nina.
So hopefully you guys are already writing. So try to keep up with everything that I'm doing.
Private Ride Mixes, the instant remedy for stiff waistlines, antisocial behavior, and a bad sex life. You want to know where we coming from? Say you want come look for me. If you're willing to have some fun, I will keep you company. Move down it, come here, grand down right by it. Squeeze her tight, make a trip down it. Neighbor, oh, that's your kind of. He's strolling on a mango sweet. Strolling on a mango sweet. Tell me how it right and sweet. Strolling on a mango sweet.
All right, so on the number theory and computation, these are all the topics we're going to touch on. We'll try to touch on today, and then tomorrow we move on to consumer. So just let me know when you guys are finished. For those who came late, I recommend you take a picture so that we can move on. So take a picture. This is your checklist. Sorry, the music a little loud and I can't find the remote. Hold on. All right, so everybody got it? So today we're not necessarily teaching, but we're just going to revise these basic properties, everything that you need to know. So once you are ready, just type ready and we're going to jump right into the session. So that's 3 persons saying ready, waiting for everybody else. So Austin, Gwen, who else? Tisha, let me know if y'all here and ready, please. All right. So sorry, I'm trying to do a lot of things at once. So let's start with fractions, basic revision of fractions. So we have the 4 operations: addition, subtraction, multiplication, and division. So we need to make sure we understand and remember the rules of each individually. Then how do we operate with a combination of a few? So I'm just going to do a few examples to just refresh your memory, right? So 1/4 plus 2/3. What we should remember about the rules of addition and subtraction is that the LCM must be the same. Once the LCM is not the same, it is our job to find a common LCM through the LCM, which is the L lowest common multiple. Sorry, people calling me and I don't know why. All right. So as we go, we know we put the line to find the LCM, and we know the LCM of 4 and 3 is 12. So our common denominator is 12. So we know we need to change 3 to 12 by multiplying by, 4 to 12 by multiplying by 3. Whatever you do to the bottom, you do to the top. So you get 3. Plus, same thing here. How do I get 3 into 12? I multiply by 4. Whatever I do to the bottom, I do to the top. So 2 times 4 is 8. So we see here, our answer is 11/12. If by any reason or chance this was an even number, we need to remember we always break it down to its lowest terms. So everybody got it? Say got it quickly and we move right along, because all of this is just simply a quick reminder. No, we will never ever get something so easy. So one of the things we would always come across is mixed fractions. So we need to remember how to change a mixed fraction to improper fractions, because in any case, most of the questions will be involving improper or mixed fractions. How do I change this? We know we multiply the denominator by the whole number and then add the numerator. So it's going to be 5 times 2, which is 10. 10 plus 1, which is 11. And we put it back over the old denominator. Yeah? So anytime we have questions that are requiring us to add, multiply, subtract, divide any type of fraction, we should remember to always change it to an improper fraction first. Okay, so similarly, if I gave you 11/4, do we know how to change this into a mixed fraction? So I'm just gonna take off the music completely so we could just have some. But if my phone, all right, so this should be good enough. All right, so how do we change a improper fraction back to a mixed fraction? What we should remember is that this has a meaning. This actually means 11 divided by 4. Always remember that. So when you divide 11 by 4, how many whole numbers can I get? I could get 4 from this 2 times. How do I know? 2 times 4 is 8. So when I take out this 8, because it's represented as the 2, what is left back? 3 is left back, and we put it over the old denominator, 4. Everybody got it? Let's go, let's go. All I need you guys to do is give me feedback, confirm that you're with me. Now we're going to move along into multiplication and division, which are similar. What's the difference between multiplication and division? So let's try multiplication first. If I have 1 over 5 times 10 over 13, how do I know if I can multiply these fractions? What's the major rule here? Canceling. You must cancel, and there's 2 ways you could cancel: up and down or diagonally. Why? Because you could only cancel a numerator and a denominator. You cannot cancel 2 denominators. You cannot cancel 2 numerators. Okay, so in this example, I see that I can cancel diagonally 5 and 10 because they have a common number, which is 5. So 5 into itself once, 5 into 10 2 times. Once you cancel as fast as you can, what do you do next? You multiply straight across. So 1 times 2 is 2. 1 times 13 is 13. Everybody with me? That's right. Excellent feedback. Now, when it comes to division, there's a specific rule. What's the rule? Switch and flip. So we know, for example, if I have 2 over 3 divided by 1 over 3, I know some stuff have to happen. What do we switch? We switch the sign to multiplication and we flip the second fraction. So that becomes 3 over 1. And we follow the multiplication rule, which is cancel either up or down or diagonally. So 3 into itself once, 3 into itself once. So we have 2 times 1 is 2. 1 times 1 is 1. And what do we know? Anything over 1 is a whole number, 2. Everybody with me? So let us look at a basic CXC type question, because this is what you're going to get. You're going to get, I'm just going to make up one. Plus 1 and 3 over 5 over 1 over 3. First thing first, what do you remember? You got to break this down. You always rewrite this so that it makes sense to you. And what does this mean? It means everything to the top is being divided by, because that's what this line means. This line means division, divided by everything to the bottom. So this is equal to 2.5. So step 1 is always to make it one linear equation divided by 1 over 3. Everybody following me? So that's step 1. Hello, 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 hello. Sometimes it could be a whole operation down here. Sometimes it could be a fraction plus a fraction minus a fraction. It doesn't matter. You just put it like this. And obviously you would end up with 2 brackets, a brackets to the top and a brackets to the bottom. Now, what would be our next step here? We have to change all of our mixed fractions into what? Improper fractions. So let me go. 2.5 would be 2 times 2 is 4 plus 1, 5 over 2, plus 5 times 1 is 5, plus 3 is 8, 8 over 5. Put that back in brackets, 1 over 3. So everybody with me? Another thing is about how you set out your answer. Do you realize my equal signs are under each other? Do you realize everything is flowing? There's nothing I have to the bottom here that's not to the top here. These are the things we need to pay attention to, okay? So let's go. What do we work out first? We always work out what? The brackets. Because it's addition, we know the addition rule. Find the LCM. So the LCM is 10. So we multiply by 5 to the top and the bottom. So we got 5 times 5 is 25. Right? Plus, same thing here, times 2. What happens to the bottom happens to the top. So we get 16. Look at what I am doing. Am I going straight and working out this answer? Look at what I am doing. I am doing everything step by step. Everybody with me? Because what students would do is go and find an answer for this and put equal here. No, you can't do that because you have to keep an account the divide by a third. So let's go. So we come down and don't be afraid to write as much as you can. Use the space they give you. So 25 plus 16, you got a calculator. Use your calculator. That should be what, 41? Confirm for me, please. So we got 41 over 10 divided by 1 over 3. So you continue because this requires its own step. What's the step? And you realize I keep bringing down the equal sign. Everybody see the equal sign under each other. Don't go have it up and down all over the place. Keep it linear. So you bring it down. So you're going to end up with 41 over 10 times 3 over 1. Can I cancel anything here? Not one thing. Everybody see that? Not one thing. So what do? We multiply straight across. Yeah, but you see, that's not going to help you with CXC because sometimes they just set you up to make mistakes like that. So always change it to the improper fraction first, okay? And everybody also realize that I did not change this back to a mixed fraction. You don't do that till the very, very, very end. And sometimes it does even accept the improper fraction answer. So this will become 123, thank you, Janella, over 10. No, let's say you need to change this back into a mixed fraction. What do? You get your calculator. Put in your calculator, how many times can I get 10 from? So you're going to say 123 divided by 10. You should end up with 12. Then you're going to know 12 times 10 is 120. So you subtract the 120. What you're going to get left back with? 3 over 10. That ain't the same thing as 12.3. But they don't want it in a decimal fraction. They want it as either a mixed fraction or improper. So if you got it, say got it. Let's go, guys. Let's go, guys. All right. So guess what we're going to do next? I'm just going to quickly go through square numbers. So what do we mean by square numbers? Remember, we're going to memorize them. So this is just a quick revision of the square numbers. 1 square, 1. 2 square, 4. 3 square, 9. I think I should write these numbers down. 4 square, 16. 5 square, 25. 6 square, 36. 7 square, 49. 8 square, 64. 9 square, 81. 10 square, 100. 11 square, 121. 12 square, 144. 13 square, 169. 14 square is 196. Please back check. 15 square is 225. Because this is all out my head. 15 square, 225. And I think we went up to 16 square, 256. And 17 square, I think is 289. Somebody check the last one for me. And let's be real, you should already have the first 10 lock. So your focus is making sure you know from 11 to 17 square. When you finish writing this down, say finish and we're going to move right along. You correct? Okay, excellent. Thank you. So copy these down. If you hear me chewing, sorry, because I'm trying to multitask. Finish, finish, finish. All right, up next we have place value and value. So We should know what I mean, right? What's the difference between place value and value? So I'm going to write a number. I'm going to call certain digits, and you're going to let me know what is the place value and value of those numbers. So there we go. Big number. 21457.8.2345. Which one? What you in here in a while? Place values and values? No. Here's the trick about these numbers. Do you just try to guess which number is what digit? What is something that allows us to see the place values better in the commas? We know the point separates whole numbers, which is on this side, and decimal numbers, which is on that side. Agree? Then we know that every 3 digits, we should have a comma. So starting from the back, you don't start from the front, you start from the back. So because I want this to be a little bit more difficult, I'm going to add another one. So going from the back, that's 1, 2, 3, comma, 1, 2, 3, comma. So just looking at this, I could tell immediately millions, thousands, place values, hundreds, tens, ones. Everybody see now? So question 1, what is the place value of the 5 in the whole number section? What's the place value of this 5 here? Quickly, quickly, quickly. You see, that's why we're here. 100. 100. Because you have to make sure you don't forget that there's something called hundreds. So, place values, ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions. Let's go over on the other side. What's the first place value after the decimal point? Tenths, hundreds, thousands, tens of thousands. Everybody with me? And so we know that the place value is the word or the position that the digit holds, whereas the value is the quantity. So quickly, what is the value of the 4 that is circled? What is the value of the 4? What is the value of the 4? Anybody? Both of you guys are wrong. Value would be 4 out of 1,000. Everybody with me? Value. And sometimes they're going to say, what is this broken down to its lowest terms? So, you know, if you didn't know, 4 could go in, it's almost like 100. Think about it like 100. So 4 could go into itself once, 4 can go into 125 times, and you put back the 0. Everybody realize that? Everybody see how I did that? 4 can go into 125 times, and you add back on the extra 0. This is mess up students all the time in the exam. Simple mistakes. Anyways, everybody okay now with place value and value? So nobody should ever make a mistake when it comes to this. Because guess what we're going to move on to next? Base conversion. I actually took some time in a specific class going over this. So I'm going to go over it again. We use base 10. That's the number system that we use. We have 10 digits that we use. What are our 10 digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers that we combined to create all of the numbers that exist in our counting system. Everybody agree? Similarly, so base 10 have 10 digits. Base 2 has 2 digits, and you always start at where? You always start at 0. So the 2 digits that exist in base 2 is 0 and 1. This is also called the binary system. CXCers use this word a lot. When they say binary, binary means base 10. If you know you don't know this, take note of it immediately. So just to give you an idea again, base 3 has 3 digits. What are the 3 digits in base 3? Quickly, anybody? What are the 3 digits in base 3? Excellent. 0, 1, 2, 3. So what we're going to do right now is we are going to go over how to change another base to base 10. Change to base 10. And the second thing we're going to revise is change from base 10 to any other base. All right, if you're ready, say ready, because we're going to use some examples to get this done, okay? So let me know when you're ready, and we're going to jump right along. Okay, so I'm going to give you a number in base 4. 1, 3, 2, 4. But before I get into this, I want to make sure everybody understand how to expand a number. So let's say I give you 123 in base 10, and we don't really write base 10. Any number that's written alone, we understand it's base 10 because that's the base value that we use, right or wrong? If I asked you to expand this, how would you expand this? This would be 1 times 100 plus 2 times 10 plus 3 times 1. Agree or disagree? No, look at this. 10 to the power of 0 and 1. So it's almost like saying 3 times 10 to the power of 0. Look at this now. This ain't the same thing as saying 10 to the 1 power. And this ain't saying 10 to the 2nd power. Everybody see that? Everybody see the connection? So with this concept, this is how you convert any base back to base 10. So let's check out the example. Let's look at this digit. 132 base 4. We want to change this back to base 10. Changing back to base 10 always include expansion, just like what we did just now. That's the way to remember it. Expansion are used in multiplication. So let me work out this concept. What would be the first place value for base 4? So 132 base 4 would be equal to, and this is how I'm going to do it so you could see. Leave the space. Everybody with me? Talk to me, talk to me. Because we're using base 4, instead of 10 to any power, what would it be? Wouldn't it be 4 to the power of 0, 4 to the power of 1, 4 to the power of 2? Everybody see that? Remember, in base 10, we did this already. In base 10, you realize that's why they call it base. Look at it. In base 10, it would be 10 to the 0, 10 to the 1, 10 to the 2. What base is this we're in currently? The same base 4. You seen it now? So let's work this out. This is going to become what? 1 times, we're changing it to base 10. That's how you change any number to base 10. So it's going to be 1 times 4. What is 4 to the 2nd power? 16 plus 3 times 4 plus 2 times 1. Everybody see that? So just like how in base 10, what are our place values in base 10? Our place values would be ones, look at here, ones, tens, hundreds. But what are the place values of base 4? Ones, all of them got ones, but instead of tens, what do we have? Fours. Instead of 100, what does base 4 have? 16s. Let me know if you got it, please. Because this is something revision. All of this is revision. So there we go. All of this now is just easy maths. 1 times 16 is 16. 3 times 4 is 12. 2 times 1 is 2. So when you add it, what's our answer? 16 and 12, that's 28. 28 plus 2, 38, sorry. 38 plus 2, 40. So 132 in base 4 is equal to 40 in base 10. Everybody see that? Yes, 30 because 28 plus 2. No worries. But everybody, let me know if you see it. So honestly, I think this is something you need to write down in terms of changing any base to base 10. In the meantime, let me just quickly explain how to do the opposite. How do you change any base 10 back to another base? So let's look at this example quickly. This number 3, 1, 2 is already in base 10, but I want to change it to base 5. Look at maths. How maths does work? If to change it to base 10 is multiply, how do you change it back to another base? What do you think you have to do? What is the operation? It's going to be the opposite. You got to divide. So that's how you remember it. To change to base 10, you use the expansion, which involves multiplication. So the opposite would require you to divide, but it's not regular division. It's a table division, sorry. So check this out. You do your T table. That's what you call a T table. All right, if you're ready for the quick revision, let me know if you're ready. Let me know if you're ready. Let me know if you're ready. So 3, 1, 2 would go here, and 5 will go here. All right, so there we go. This is just a regular division, except you really want your remainders. You want your remainders, and the remainders is actually the most important part. So let me run it. 5, and I'm going to do it by digits. 5 can't go into 3, but 5 can go into 31 6 times, remainder 1. 5 can go into 12 2 times, remainder 2. Everybody see that? It's just like you're dividing, to be honest with you. So there we go. We're going again. You have to keep going until you reach 0. You have to keep going until you reach 0. Now, this one a little retarded because you're going to see why it's retarded. So we're going to do something else to kind of show you how it's going to really work. But for now, just follow me. So we're going with 5 again. 5 can go into 6 once. 5 can go into 6 once, remainder 1. 5 can go into 12 2 times, remainder 2. Let's keep going. Divide by 5 again. 5 into 12 2 times, remainder 2. Did I reach 0? I did not reach 0. I have to keep going until I reach 0. 5 can go into 2 0 times, remainder 2. And guess how you write your answer? Your answer must be written from the bottom go up. So what does that mean? That means that our answer is 3 1 2 in base 10 is equal to 2 2 2 2 base 5. And I want to check it. Let's turn it back and see if we get back 310. So let's go. We want place values, right? So let's write it 2 times something. How much 2s? We got 4 plus 2 times something plus 2 times something plus 2 times something. So let's go. What is the place values? You always start to the back because it's easier. 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3. Everybody with me? Everybody with me? Remember, we're changing it back to see if we get back this answer. We're back checking. So that would be what? We have here 5 times 5 is 25. 25 times 5 is 125, right? So 125 plus 2 times 25 plus 2 times 5 plus 2 times 1. So there we go. That would be 250 plus 50 plus 5 plus, no, that's 5, 10 plus 10 plus 2. 250 and 50 is 300, 310, 312. Everybody see now? Hello, talk to me, talk to me, talk to me. So we see all I did was take the same answer that we got and back check to see if we got back the answer. Remember, how do you change anything from another base to base 10? You expand. That's what I did here. And when I did that, I got back my original answer. So that is how I know I am correct and that this is the answer in base 5. Okay, so just a quick revision. To change any base to base 10, you expand using their bases, place values. And I showed you how to find the place values of any base. It's always going to be the base 0, the base 1, the base 2, the base 3, the base 4. And y'all realize where I started? Where did I start? From the back. Then when it comes to changing base 10 to any other base, you got to divide until you get 0. And then what do? You take the remainder from the bottom, go up. So hear this joke now. Let me change 40 back to base 4. So you see how we did this? Let's see if we could get 40 and change it back to 132. Base 10 is the highest base in the number system. Yes. Excellent question. So there we go. We want to change 40 into base 4. How do we do that? We know we got to do our division table. So you set up a T table. I know we're moving a little fast, but remember today is just summary notes. All of this is revision from top to bottom. I'm not teaching necessarily. I'm just trying to recap things that we should know already. So there we go. We're changing 40 to base 4. Let me know if you're ready. 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 So let's go. 4 can go into 40 10 times, right? 10 times remainder 0. Yeah? There we go again. 4 into 10 goes twice, remainder 2. Wait there. What's this? Base 4? Are you? Nobody ain't gonna tell me it was 30 and not 40. Anybody ain't seen it? The mistake. Remember, we had fixed it. It was 30, but then we got 40 here, so they're supposed to be 30. That's why it ain't going right. Hello? Y'all had one job. You're not gonna fire everybody in here. We gotta be vigilant. This was supposed to be 30. So it's supposed to be 30 being changed to base 4. Because I want to know what's going on. All right, we ready again? All right, ready? Let me go. Feedback of communication. Are you ready? What talking to? Let me eat a fries because y'all ain't studying me. Eat my food. I got my food getting cold and I ain't talking to me. All right. There we go. 4 into 30 goes 7 times. 7 times 4 is 28. So 7 times remainder 2. Let me make sure, see. Okay. So there we go. 4 into this goes once, remainder 3. This goes 0 times remainder 1. So what is our answer? We'd start from the bottom to the top. So we get 1, 3, 2, base 4. Hello? Everybody see that? So we're cooking on gas. So that's it for bases. So we know how to go back and forth with bases. So if that comes, you should smile because you should remember what to do. Okay. So guess what we're moving on to now? We're going to do significant figures and the rules. So sig figs. So let's go over the rules quickly. First rule, non-zero digits are always significant. If you understand that, say yes, let's go. So every rule. Oh, Max don't give topics in it because all the topics just come. I ain't know that. Max topics don't come because all the topics just come. Remember, you don't have an option anymore. You got to do everything. So they just expect you to know everything. So there we go. So the first rule, non-zero digits are always significant. Second rule, any zeros that fall, y'all want me to write it out? I don't mind writing it out. Do y'all want me to write them out? It's not me, no, it's you. It's y'all. If y'all want me to write out the rules, I'll write them out. If you don't need them, I don't need to. But if you really want me to, if you know, feel confident with significant figures. So let me write them up. Shorthand, okay? What happened to this? Is it dead? Oh no. All right, so here are our rules. Non-zero digits are always considered significant. Zeros that are in between two significant figures are significant. Trailing zeros in the decimal section or position only are significant. And what does trailing zeros mean? Trailing zeros mean that at the end of the number, you have zeros. So it only is counted in the decimal section and not when it's behind in the whole number section. All right. So let us do a quick activity about falling or identifying the number of significant figures and even rounding it off. So I'm just going to zoom out so you could see these. And we're going to start with the first one. I need everybody to tell me how many significant figures you have counted. First one, 4250. How many sig figs? Let's go, let's go, let's go. That's 4 persons. Let's go on to everybody else. There are 9 people here. Okay. Unfortunately, everybody's wrong. Why is everybody wrong? Do we have trailing zeros? Yes. But is it in the decimal section? So when it comes to counting which digits are significant, 4 is significant, 2 is significant, 5 is significant, 0 it is not, because this is not the decimal portion. So it's 3 sig figs here. Next one. 7080. How many significant figures? Let's go, let's go, let's go, let's go. Let's go, let's go, let's go. Because how are you going to round off a number to something and you don't know how to identify how much they are already? So if I was to tell you, round this off to 2 significant figures, you don't even know. You have to know how much significant figures there are already. So you guys are correct. Excellent. This 0 would be counted. So this is obviously significant. This 0 falls in between 2 significant, so it's counted. This is obviously significant and this is not. So that's 3 sig figs. Excellent. Next one. 3. How many significant figures here? This is a setup, eh? Let's go, let's go. How many significant figures here? I need to see more people responding. I'm not asking for a paragraph. I'm asking for one answer. The answer is 6. This is a hard one. And I'm going to explain to you why this is a hard one. So there we go. This is obviously significant. This is obviously significant. Aren't these zeros in between 2 significant digits? Everybody? So they are significant. Now here's what turned this question upside down. This is a 0 at the end, which is not in the decimal place. But you see this point changes everything. Because guess what? This point, because this 0 is in the decimal place and it's to the back, it is significant. Do you agree? Do you agree? So wouldn't this 0 be constituted to be in between 2 significant figures then? So therefore in itself is significant. You see why that was a bit challenging? Everybody see that? So this one would be 6. This point changed everything. Once this point dropped here, this point made the 0 significant. And because this was significant, and we know 5 significant, the 0 end up falling in between them. All right, so let's try another one. That one was a hard one, and that's the intention of giving it to you because it's important that I know you understand it. So let's try this one now. 0.00703. How many significant figures? Stop being afraid of getting things wrong. Let's go, guys. How many significant figures here? Okay, so that means you forget the last rule. What's the last rule? What's the last rule? You start counting as the first non-zero digit. So do we count the first 0? We can't count this. We gotta start counting at the first non-zero. So this is not the first non-zero. This is not the first non-zero. This is the first non-zero. Then the 0 falls in between the 2 of them. So it's counted. And obviously 3 is counted. So it's 3. Okay. Please know that all these questions are specifically selected to strengthen your understanding. So if you made a lot of mistakes, that's okay. So let's try this one. 5030.0. How many significant figures? We should be getting stronger though. So let we go. We should be getting more confident. We should be getting stronger. Don't forget the rules. What makes each digit significant or not? Is the zero between two significant figures? Is there a decimal point? Is there trailing zeros? You have to remember all of the rules. So let we go. We know this 5 is counted. Is the 0 counted? Yes, because it's in between a 5 and a 3. The 3 is obviously counted. And just like the example before, we got a point. So that means this is counted. Hence, this 0 is also significant. So the answer is 5. Last one, a hard one. And then we're moving along. F. 750.064080. How many significant figures? There we go, guys. Only 2 persons answer so far. Let's go. How many significant figures here? Excellent job. It is 9. All of these digits are significant, so the answer is 9. All right, how y'all feeling about significant figures? A little better? So remember the 4 rules. Remember the 4 rules. Similarly, rounding off to significant figures should not be difficult. So you should know how to round off any number. So let's quickly just do a few rounding off, and then we're going to move right along. So we know if we have any number or any decimal, let's say 4.36. If I want 1 DP, I identify which number is in my 1 DP place, which means I want nothing else. So I got my cutoff line here. This number is 5 or more, so 3 would increase to 1 by 1, so it's 4.4. Yeah, so we should be good with that, right? Can I move on from this and go into scientific notation? Excellent. Now, when they talk about scientific notation or standard notation, one of the things you must keep in your mind is that how your answer must look. It must have 1 digit, let's call it 1 digit A, point, B, C, D. So the truth is, it doesn't matter how much decimal point digits come after. There should only be 1 number in front. Then you must have times 10. Now, this is the tricky part. You got 2 options for the power. It could either be a positive number or a negative number. What tells us that the power should be positive? But even before you answer that question, what tells us what number is the point? What number is the power? Sorry. The power is determined by the number of jumps you have to make to get the point to be in between here. The power is determined by whether the starting number is either greater than 1 or less than 1. So let's look at 2 examples with the same exact digits. 1, 2, 3, 4.56. That's 1 number. 0.000123456. All right, so there we go. Based on what we see here, for both examples, between which 2 numbers should the point be? Which 2 digits should the point be for both of them? For both of them, it must be between the 1 and the 2 because we only want 1 digit there. So let's look at the movement. That's 1, that's 2, that's 3. So this is where our point is. So what is our answer? 1.23456 times 10. What would be my power? The power of 3. Why positive 3? Because our beginning number was 1,000, something that's definitely greater than 1. Agree or disagree? Now let's look at another number. We want the digit between 1 and 2 again, so we got to move the point. 1, 2, 3, 4. So what is my answer? 1.2346 again times 10, but instead of positive 4, what will it be? Negative 4. Because our beginning number was less than 1. Everybody see that? Do you know we could change this number to significant figures? So this is my question now. What are these numbers to 3 sig figs? Both of them. What are these numbers to 3 sig figs? You just do the same rule. You want 3 figures, right? You count it. 1, 2, 3. So I want to cut off here. Would this 4 affect the 3? No, because it's less than 5. So what would your answer become? 1.23. And guess what some students just forget? The most important part. The times 10, this part don't change. The only part that changes is that instead of this long decimal, you have a neater decimal. Same thing over here. So it's going to be 1.23 times 10 to the negative 4. Everybody see that? So it is possible to round off a standard form to significant figures, even decimal places. If they wanted 1 decimal place, is the same concept. So if you're good to go, say good to go, please. We are almost done with number theory and computation. So I am hoping that you guys are getting a good sense of everything. So let's take, let me see. But if they didn't ask, leave it. Exactly. You don't do nothing unless they ask you. If they say exactly or they ask for the answer, you leave it just so. Only if they say round it off to something, that's when you do it. So let me go through this here. So what have we done so far? Addition, subtraction, multiplication of fractions and compound fractions, square numbers, place value and value, base conversion, significant figures, running off to decimal places. So now we did scientific notation, so I skipped this. Now we're going to go through the number properties. Be honest, out of the 1, 2, 3, 4, 5, it's really 6. Out of the 6, how much do you know right now? Out of 6, let's go quickly. 5 out of 6, 3 out of 6, 2 out of 6, none out of 6. What do you know? What do you remember? I am watching. Because this comes, you know what makes this information important? When they say prove that this is the commutative, if you don't know what commutative is, well, you can't do nothing. You can't do a thing. So it's important to be able to know what these terminologies mean. So let's take a look at all of them. So let's look at first, let me see. Y'all hearing me still? I just see a little glitch in the light, so that's why I kind of panic. So if by any chance y'all see me disappear, it's probably like something happened with electricity, okay? And once that happens, it is messed with Wi-Fi. All right, but we almost finished because as you see, we only have these laws to do and ratio. But I feel confident with ratio because we've done a lot of ratio. So let's get into closure, commutative, associative, distributive, identity, and inverse. Now, one of the things I need you to know, these are used in every other topic. So when you do functions, it is possible for them to say, prove that this is associative, prove that this is commutative. Even in matrices, we've done it. We've seen how to prove if two vectors or two matrices are commutative. So let's go back to closure. Closure means that when I have 2 types of numbers, so let's say 2 times 2. You should know 2 is a whole number. Agree or disagree? And 2 is another whole number. Will your answer be a whole number? So that means in this example, multiplication is closed. That's what closure means. If you have one type of number and you multiply it by the same type of number, if your answer is the same type of number. Let's try integers. -3 times 4 is negative 12. Is this closed? And that's how they describe it. Is it closed? Yes, because negative 3 is an integer. Because if you remember, integers are positive, negative numbers, and 0. Right or wrong? So we should remember all the types of numbers. You should know whole numbers. You should know what natural numbers is. Where does whole numbers begin? Whole begins at 0 until infinity. Natural starts where? At 1. I hope I remember these things, eh? Integers are positive, negative, and 0. What other type of numbers we have? Rational numbers. We should know what rational numbers are numbers that can be written as a fraction. 2 over 3, 0.45. What numbers are not rational? Pi is not rational. You know why pi is not rational? You can't write pi as a single fraction. You know, when I mean single fraction, you can, 22 over 7. But realistically speaking, that's a rounded off figure. Pi is actually a decimal that goes up to infinity. It doesn't stop. Anybody know that? So if somebody said the square root of pi, that's not a rational number because you can't express that as a single fraction. Okay? When you see weird things like negative 6, can you square a negative number? So that's irrational. Okay? So that's just something you need to be mindful of. Oh, another thing you need to know. You could say 0 divided by 6. Sorry, it's stuck. 0 divided by 6 is 0. Because let's be real. I can't divide nothing into 6 parts. Everybody see that? But I cannot divide 6 by any number. Anytime you do this, you're going to get undefined. Impossible. Anybody got a calculator? Put this in your calculator, you see something. Put 0 divided by 6, you're going to see, tell you 0. But put 6 divided by 0, you're going to see error. Do it now. Do it right now. Let me know if you see, you prove it, that you're checking back check. Everybody see that? Now, why am I teaching you this? I'm going to show you something. It comes up in these cases. Suppose they say you have this fraction 1 over 3 minus x. And they're going to say, state the values of x that makes this fraction undefined. You should know what would make this undefined. The only way this is undefined is if it's 1 over 0, right or wrong. What can x be that would make this 0? X would have to be what? 3. Everybody with me? So that means x could be any number except who? 3. This does come in functions. This does come in graphs. This does come in every single topic. Just remember that the word undefined in maths means that you try to divide anything by 0. That's the whole concept of the word undefined. So if you see a question and it say, what value of x or what value of y would create an undefined value or something that says an error, you should remember you can't divide by 0. So it must be that even if it was 1 over x, they say what value of x makes this undefined? Straight up, x would be what? What would x be? Just simply 0. Everybody with me? So I just teach you 1,000,001 things there just now. That's just a by the way thing. To me, it can't hurt to know, because let's say CXC come on a different level this year, you can't say I didn't mention it, okay? That's the importance of these revision classes. So there we go. We know and understand what closure mean. If I multiply, if I add a whole number to a whole number, I get a whole number. But check what's going on. I'm going to tell you the truth. You see addition and multiplication, they always obey the rules. Guess who don't obey the rules? Guess who are the gangsters of maths? You should know. Who is the gangsters of maths? Subtraction don't care about nobody. Division don't care about nobody. Because look at this. I could have 2 minus 3. Both of them are whole numbers, right or wrong. But what answer it's going to give me is going to give me an integer. So that means that subtraction is not closed. Same thing with division. I could divide two numbers. 2 divided by 3. Do I get a whole number? No, I can get a fraction. It does not close. Everybody with me? If you got it, say got it. Good. All right, so let me keep it moving. So we got closure down pack. Commutative, man, everybody should know commutative. If you know commutative, I bust through the laptop and scuff you. Who know what's commutative? If I tell you A plus B must be what? B plus A. If you switch the order, it remains the same answer. That what commutative mean. Addition obeys it, yes. Who else does obey it? A times B is the same thing as B times A. Multiplication obeys it. Who do not obey this? Just from based on what we talk about. Who don't obey this? We don't know subtraction ain't gonna obey. Division ain't gonna obey. Because look at this. 2 minus 3 is the same thing as 3 minus 2. It is not. 4 divided by 2 is the same thing as 2 divided by 4. It is not. So commutative, you just switch the order. A plus B is equal to B plus A. Closure just means if I add two numbers of the same type, the answer must be the same type of number. Commutative, you switch the order, the answer must be the same. What does associative tell us? Associative deals with 3. If I have A plus B plus C, A plus B plus C. Look at this. If I add these two numbers first and then add the third number, wouldn't it give me the same answer if I had add the second two and then add the first after? What can you guess from this? What can you guess from this? Who does obey the associative law? Addition and multiplication. Who do not obey this law? Subtraction and division. Everybody with me? So what's the difference here? Here, it must be 3, at least 3 or 4. And this picks a specific grouping of elements. When you add the different groups, you can still get the answer. It doesn't matter. Now, let's look at distributive. We should know distributive. We're into distributive a lot. If I got A outside and B and C inside, what does distributive mean? This means A times B. Sorry about that. A times B plus A times C. So distributive means that I am taking one element on the outside and distributing it by the elements inside. We multiply everything on the inside by everything on the outside. So that's going to be A times B plus A times C. Everybody remembering it now? Because this shouldn't be new, right? This is our revision, right? What did you also learn now that we're here? Isn't factorization the opposite of distribution? So let me look at this. You get AB plus AC. If I start off with AB plus AC, can't I factorize this? Doesn't both sides have something in common? What both of them got in common? Both of them have in common A. So when you pull out A, what's left back? B plus C. Don't forget that all these things we learned already. So let's go back up to the checklist quickly. So we locked down commutative. Commutative means A plus B equal B plus C. We locked down associative. Associative is when you have 3 elements. And if you add the first 2 and the second 2, you're going to get the same answer still. And distributive means you got something on the outside of the brackets where you mean multiply everything outside by everything inside. So this would be AB plus AC. Now, before I continue, everybody have these here locked? If you're good to go, say good to go. Give me some feedback quickly. This is a lot of revision for one night, but we got to do it. We got to do it. We got to do it. I hope it's helping. I hope it's making you feel a little sharper, a little bit more confident, because that's what you need going into this exam, confidence. If something hard, that don't mean you give up. You keep thinking, you keep fighting. So let me go. Last 2. We should know what identity means. So under addition, we're going to look at addition and we're going to look at multiplication and division. Always paired, if you realize. When it comes to addition, what is the identity? When I say identity, it does not change the number from being the number. So if I got 3, what can I add to 3 that ain't gonna trouble 3? What number do I add to 3 that would not affect 3? Thank you, 0. So what does that mean? 0 is the identity for addition. Regardless of what you add to 0, it's not going to change the number. So similarly, what would be the identity for multiplication and division? What can I multiply by any number, divide by any number that's not going to change that number? 1. Very good. Now, let's touch on inverse. You have additive inverse and multiplicative inverse. And we did this already. We know the additive inverse is what? A negative of the number. So if I got 3, what is the inverse, the additive inverse of 3? -3. How do we know? When you add the inverses, you must get back the identity. You know that? When you apply the 2 inverses, you must get back the identity. We didn't learn that in matrices as well. So this would be, clashing signs would be minus. So 3 minus 3 is 0. Similarly, for multiplication, if I got 3, what's the inverse of 3? 1 over 3. Remember, 3 over 1, 1 over 3 is the same thing. Inverse, upside down, flip it. When I times the inverse, what should I get back in? The identity. What's the identity? The identity is 1. When you multiply 2 inverses, you must get back the identity. If it's the addition inverse, you can get back 0. If it's the multiplication inverse, you can get back 1. Hello? Y'all with me? Anybody remember how to write the inverse? Another way of writing inverse of 3? 3 minus 1. Remember, these 2 things mean the same? All of these things we need to remember. All right, so guess what? We are done. But before we move on, we need to touch on ratio. Now, ratio is a general concept. What is the concept? What is always the steps for the concept? Match the quantities. What do I mean by match the quantities? So step 1 is match the quantities. Step 2 is find one share. Step 3, find any amount of shares. So let's try an example. I'm just gonna make up a little something here. And I'm gonna vary the same example. So Tom and Pat has, what they have, guys? Somebody give me something there. What they got? Money? Has $100 shared in a ratio of 2 to 3. Now, based on this, what is the first step again? Match the quantities. What do I mean by match the quantities? You match whatever it is they're sharing to the number of shares. So when we look at $100, what does $100 represent in the total money to be shared? Only Janella answer me. We're causing this. Yeah. Good. So what value would I match with 100? So I know $100 would represent what type of shares? How much shares $100 represent? Five shares. Everybody see that? Suppose I had say Tom's share was $50. Would it be the same? What would the matching look like then? How would the matching for this specific statement would be? It would be 2 shares to what? Equal to what? $50. Right or wrong? You got to match what they give you. If they give you Tom's share, you match Tom's share with Tom money. If they give you total shares, you match the total shares with the total money. If they give you the smaller share, remember sometimes they just do that. They would say, "Oh, the smaller share." You match the smaller money with the smaller share. If they ask for the bigger share, you match the bigger money with the bigger share. You match what they give you. It does not matter. No. What is step 2? What is step 2? Find one share. We don't know how to do that. If you know what 5 is, don't we know how to find one? You divide by 5. Wherever you do on one side, you do on the opposite side. So one share is what? What is one share? $20. Now let me ask you a question. If you know what one share is, shouldn't you be able to find 40? What do you do to find 40 if you know what one is? And that's what we call units. I didn't say $40, I said 40 shares. It got to be times 40, guys. You see the mistake you make there? I didn't ask for $40, I asked for 40 shares. If one share is 20, it got to be times 40 on both sides. If I ask you for 2 shares, what you're multiplying with? By 2. If I ask you for a half a share, you multiply by 0.5. If I ask you for 26 shares, you multiply by 26. Everybody see the steps? Match the quantities. Find one share. Find any amount of shares. That is ratio. That's literally it. Match what they tell you to match. Find one, find any. Hello? How y'all feeling? That's it for number theory, you know? Hold on there, let me back check to make sure I touch upon every single thing. I think I touch upon every single thing. That's it for everything for number theory. So guess what? Tomorrow, what time it is now? Because I got some stuff to do. So tomorrow, to be honest, this is how all class is gonna go. Each class gonna focus on one area and I'm gonna go through every single thing under that one area. So tomorrow is consumer. Well, we still got a little bit more time. We can start consumer now, you know. Y'all want to start it, even if we do 15 more minutes. I'm willing to do 15 more minutes. And you know how consumer be, to be honest. And if we do consumer, of course, anything you want. I feel, because to be honest, if we could get all these easy stuff out early, we could spend more time doing the harder topics. If you have to leave, you can leave. I'm willing to go up until I do a 15 more minutes. I could do a 15 more minutes. I'm gonna do a 15 more minutes. Because consumer is just a lot of percentages. Oh, I realize that. Yeah, I realize consumer is just a lot of variations of finding percentage. Hello. It's just finding all these different percentages, percent of that. So what I'm gonna do, rather than doing every single thing on the consumer, I'm gonna focus on the more difficult stuff. I am just gonna focus on stuff that kind of creates a little trigger for people. And so what I'm gonna do, I'm not gonna go over everything. Yes, it's gonna be recorded. Everything is recorded and posted. So I'm just gonna run through the formulas. Me ain't doing nothing else but the formulas, to be honest. Only the formulas are posted and that's it. Because I'm gonna be honest with you, consumer, we've killed consumer. We've killed it a lot. And it's just making sure you have the formulas unlocked. So I'm gonna go through the list, and every time I call a topic, you're gonna let me know if you got it or if that's something you want us to touch. Because yeah, I don't have to go through the whole of consumer. So there we go. Ready? If you're ready, say ready. Remember, there's no such thing as too much revision. There's no much thing as being over prepared. You may think, you know, that don't mean you can't get stronger, you can't get better, you can't get more confident. You see me? Yeah. All right, let me go. First thing, I'm gonna call these 3 things together. Exactly. Let me do these 3 together because they come together. They're the opposites of each other. So let me tell you the first pair. The first pair is profit and loss. Easy stuff. Everybody got that. You should be able to find profit and loss, profit percent, profit discount, percentage. The only thing I'm going to touch on is the formula for profit percentage. And we should know the percentage profit is just profit over CP times 100 over 1. Percentage loss is equal to loss. It's always out to the CP times 100 over 1. Yeah? So we got a lock. What is the other two pairs? Discount and tax. Discount and tax is the exact same thing. What is the difference? Instead of subtracting for discount, what do you do with tax? You add. Literally, that's it. Same thing. Next one. Hire purchase. How we be with hire purchase? We should know the formula. Hire purchase is the deposit plus total installments. And how do we find total installments? Total installments is the number of months times the amount you're paying for each month. Right or wrong? And you know, deposit is what? A down payment. If you got higher purchase, let me know if you got it. Next, simple interest. Simple interest, easy. We should know this formula already. SI equal PRT over 100. And we should be able to find every other letter. We should know how to find P. We should know how to find R. We should know how to find T. So there we go. It's always what? SI times 100 for all three. SI times 100. That's the numerator for all three. SI times 100. And what's the denominator for P? The other two. R times T. What's the denominator for R? P times T. What's the denominator for T? P times, oh God, get with me way. P times R. I singing good, you know, I singing good. I singing good. Excellent. No, compound interest. Yeah, remember compound interest. What is the concept of compound interest? It's different because it's two things you got to look for. The interest at the beginning of the year, or the beginning of the year, and what? At the end. Right or wrong? And remember, every year it goes up. So let's build that step. Let's build the step, because this is something you have to remember. You gotta do it step by step. If you want the interest after 2 years, when it comes to compound interest, you can start up. You got to calculate the year, the first year, at the beginning of the year. This thing sticking. So there we go. Year one. Start. Year one end. And how do you get year one end? In the original plus the extra interest you calculated? Talk to me. So let's say the start is the box. So what would happen with year two? What would you start off at year two? Wouldn't you start off with what you ended off with in year one? So year two is going to be the box, the original, plus the interest from year one. And you have to find the interest and add on the extra interest from that, right or wrong? So year two, at the end of year two, you're going to have the original plus the interest and the interest of that added on. I know this look a little confusing, but if you was in class, you should know what I'm talking about. You know what I'm saying? Yeah? Okay, good. Next thing, appreciation and depreciation. Appreciation. Okay, we did a lot of that in the paper one practice. So you could look back at some of the paper one videos, and we went through it in detail when it comes to that. And there's a consumer video as well. So don't be afraid to check out the consumer thing. Appreciation is when what? The value goes up. And do you know appreciation is compound? It's the same thing as compound interest. Because after 1 year, you appreciate, but it's a different rate at the second year. Do we agree? The second year, you got to calculate the first year first. You can't calculate the second year of appreciation without the first. Same thing with depreciation. What is something that is depreciate a lot? Cars. You buy a car this year, the value is this thing, but after the first year, it gone down. After the second year, it gone down again by a different rate. Everybody with me? Money conversion. What do we mean by money conversion? US to TT to Barbados dollars to EC. I taught y'all how to do the conversion to JA. I think y'all should have this unlocked already because we kill this. The only thing I want to touch on after this, we did bills. Bills is common sense. You get a bill. You don't know how to work out your bill, guys. They're going to tell you for the first 100 units, you charge $10 a unit. For the next 20 is another charge. You follow the instructions, right or wrong? Nobody should get messed up by bills. The only thing I'm worried about is salary. And so I'm just going to take a few minutes and just remind you guys about the formulas for salary when it comes to the overtime. Y'all remember overtime? So overtime, they got different terminologies you need to remember. So you're going to have time and a quarter, time and a half, double, triple. So if somebody say again double pay, what you're multiplying by? You're multiplying by 2. So if I usually get paid $10, if I get overtime, I'm gonna get $20. Everybody with me? What would be a time and a half? Time and a half is exactly what it sounds. 1.5. What is time and a quarter? 1.25. What is triple times 3? Everybody with me? So if they say you work 3 hours overtime, your normal pay is $15 and you're getting double, you know, you got to calculate your double pay. Your double pay is by using these numbers here. If they say you overpay is time and a quarter, you multiply by this. If they say it's time and a half, you multiply by this. If it's double, obviously you multiply by 2. If it's triple, you multiply by 3. No problem. All right. So that's it. The only thing is that we did it, but the only thing you need to know is by Levy is commission, and that's easy. Commission is when you work for a certain amount of things, you work based on how much you sell. You get paid based on how much you sell. So let's say you sell $2,000 of goods and your commission is 10%. What do you do to find out how much you get paid? Find 10% of the $2,000. Everybody with me? So guess what? We finish consumer. Question, yes, ask a question. So while he types his question, just a heads up, tomorrow we're doing algebra, and I know I need algebra, guys. Make sure you come class tomorrow. You know you need algebra. You know, if you don't remember all the factorizations, you don't know how to solve simultaneous equations, you know, if you forget how to do a lot of things, come to class tomorrow. Everybody with me? So we're going to do everything on the algebra tomorrow. And then this weekend, I have to work, but I'm going to try to see if I could push in an extra session this weekend so that we could do functions. So far we do question 1. That's question 1. Question 2 is algebra. Question 3 is measurement, which we did already. That's easy. It's just the formulas, right? And question 4 is functions. So these are the ones I want to focus on. I want to do algebra and functions. Okay, so that's it for tonight, guys. Before you leave, give me an idea of how you feel about today's class. Was it helpful? So out of 10, tell me how you feel after today's session. Yeah? Please don't forget the reason in the Google Classroom, there is all of the topics. Let me see if I could go on and show you again. The past paper solutions are there. You have fastpass.com. please use your time wisely. Okay, use your time wisely. All my classes moving forward are just going to be revision, like just like tonight, how we went through everything under each topic. That's what we're going to be doing. So I don't see there's nothing else that I could do to help you. You got to help yourself. Okay, if you need any extra help, nobody ain't messaging me. Me ain't seeing nobody asking me, Miss V, I speak in this area. Could I get some extra help? At the end of the day, you got to do what you got to do for yourself. I shouldn't be begging you to message me. Okay, so that's it for today. Thank you guys for being here. See you guys tomorrow. Good night.